Hello students, it is the second part of mole concept. Today we start relative atomic mass. The term relative atomic mass first of all determined by Dalton about in 1803. First, relative atomic mass, that is, atomic masses of elements are compared with the atomic mass of hydrogen. That is, the reference element was taken hydrogen. And later on, relative element is taken as oxygen. But due to few controversies between chemists and physicists, finally in 1979 all scientists, that is chemists as well as physicists, agreed to adopt carbon-12 isotope as a reference atom to compare the atomic masses of other elements. That is, relative atomic mass now is compared by the mass of carbon-12 isotope, and they use unified atomic mass unit, symbol U, based on atomic mass of carbon-12 isotope. As you know, isotopes, the different atoms of the same elements having different masses. Carbon is found in form of three isotopes: carbon-12, carbon-13, carbon-14. But as a reference, carbon-12 isotope is taken. 1U, that is unified atomic mass unit, that is the unit of mass which is adopted by scientists in 1979, is defined as 1/12 of the mass of one atom of carbon-12 isotope. carbon-12 isotoप के एक एटम के मास का 1/12 पार्ट जो मास था, उस मास को उन्होंने ये 1 यूनिट एटॉमिक मास कहा, दैट इज यूनिफाइड एटॉमिक मास, जिसकी सिंबल है U. Experimentally, it was found that mass of 1 mole atoms, and in previous video we have studied what is mole. Experimentally, it was found that mass of 1 mole of atoms of carbon-12 isotope is 12 gram. It is experimental value. Now, according to calculation, if the mass of 1 mole of atoms is 12 gram, then mass of one atom and mass of one atom is termed as atomic mass, mass of atom. So we can say mass of one atom, that is atomic mass. Atomic mass or mass of one atom of carbon-12 will be mass of 1 mole atoms divided by 1 mole, that is Avogadro constant. So atomic mass or mass of one atom will be 12 gram upon Na. But according to the definition of unified atomic mass unit, unified atomic mass unit, that is 1U, is equal to the 1/12 of atomic mass of carbon-12. Atomic mass of carbon-12. Atomic mass of carbon-12 isotope, that is mass of one atom of carbon-12, is 12 gram by Na. So 1/12 into 12 gram by Na. Atomic mass is 12 gram by Na. 12 cancel by 12 by one time. So ultimately 1U is equal to 1 upon Na gram. When the value of n is put here 1 upon 6.022 into 10 to the power 23 gram. Then on calculating, we found 1u is equals to 1.66 into 10 to the power minus 24 gram, or you can say 1.66 into 10 to the power minus 27 kilogram. And later on, SI system agreed that 1U can also be called as 1 Dalton in the respect of Dalton, because first of all Dalton determined relative atomic mass, and 1 AMU, atomic mass unit. All these are the symbols of other units used previously unified atomic mass. Hence, therefore, relative atomic mass of an element is compared with respect to 1 by 12 of atomic mass of carbon 12 isotope, or we can say with respect to 1U or 1 AMU. The definition of relative atomic mass: relative atomic mass of an element is a number which informs that one atom of that element is how many times heavier than 1 by 12 of mass of one atom of carbon 12, that is 1 AMU. रिलेटिव एटॉमिक मास किसी भी एलिमेंट का एक वो नंबर होती है जो हमें ये बताती है कि किसी भी एलिमेंट का एटम कार्बन 12 के एक एटम के मास के 1/12 से कितने टाइम्स हैवी है, मतलब 1 AMU से कितने टाइम्स हैवी है। ये एक कंपैरिजन है, एक कंपैरेटिव क्वांटिटी है, इसलिए रिलेटिव एटॉमिक मास यूनिटलेस होता है। रिलेटिव एटॉमिक मास इज यूनिटलेस। सो रिलेटिव एटॉमिक मास is equals to atomic mass of element, that is mass of one atom, divided by 1 by 12 into atomic mass of carbon 12 isotope. We know very well that this is called 1U or 1 AMU. So relative atomic mass of element is equal to atomic mass upon 1 AMU. That is why atomic mass will be equal to relative atomic mass multiplied by 1 AMU. For example, relative atomic mass of oxygen 16. It means one atom of oxygen is 16 times heavier than 1 AMU, or 16 times heavier than 1 by 12 of atomic mass of carbon 12 isotope. So atomic mass of oxygen is equals to relative atomic mass 16 into 1 AMU, that is 16 AMU. Mass of one atom of oxygen is 16 AMU. Mass of one atom has unit of mass, and that unit is AMU or U. And similarly, relative atomic mass of chlorine 35.5, that is one atom of chlorine is 35.5 times heavier than 1 by 12 of atomic mass of carbon 12 isotope. So atomic mass of chlorine will be relative atomic mass multiplied by 1 AMU, that is 35.5 AMU. Mass of one atom, that is atomic mass, has unit, it is mass, so it has unit of mass. AMU is a very small unit of mass. In fact, atomic masses of an element is the average of atomic masses of its all isotopes. So it should be called average atomic mass. Generally we call atomic mass, but strictly we should call average atomic mass. So atomic mass or average atomic mass is in fact average of atomic masses of all isotopes. average atomic mass M average atomic mass is equals to N1 M1 plus N2 N2 plus N3 N3 plus and so on divided by N1 plus N2 plus N3. What is the meaning here? N1 is the number of one kind of isotope and M1 is the atomic mass of that isotope. Again, N2 is the number of other isotope of that element into mass of that isotope, atomic mass of that isotope. N3 is the third type of isotope and N3 is atomic mass of that isotope and so on. Divided by total number of isotopes. It is called average. If N1, N2, N3 plus so on, that is the sum of all the atoms of all the isotopes is 100, then N1 upon N1 plus N2 plus N3 can be called as percentage abundance. Therefore, average atomic mass is equal to summation of percentage abundance and multiplied by molar mass of isotopes divided by 100. That is, the percentage abundance and molar mass प्रोडक्ट जो है उन सबको ऐड कीजिए और डिवाइड बाय 100 तो आपको मिलेगा एवरेज एटॉमिक मास. Now we have question given that abundance of isotopes Fe54, Fe56 and Fe57 are 5%, 90% and 5%. Respectively, the atomic mass of iron is. In this question, atomic mass of element means average atomic mass of all the isotopes. Here, the isotopes of iron are Fe54, that atomic mass of this is 54. Fe56, that is atomic mass of this isotope 56. Atomic mass of this isotope is 57. So, according to the formula, average atomic mass is equals to percentage abundance of one isotope, that is 5%, multiplied by its mass, atomic mass 54, plus percentage abundance of another isotope 90% multiplied by mass of that isotope 56 plus 5 into abundance of this isotope 5 and atomic mass is 57 divided by total number is 100. So guys, it is 270 plus 5040 plus 285 divided by 100 and it is 5955 divided by 100 is equals to 55.95. That is average atomic mass of iron or relative atomic mass of iron is 55.95. So your answer will be third. Your option is third. It is very interesting and I don't think it is a typical question. It is a very simple question. And this question is asked in IIT 2009. This question is asked in IIT 2009. Now we have another question. It may also possible that the average atomic mass is given, but the percentage abundance of one isotope is asked. In this question, let percentage abundance of chlorine 35 is X or X%. Then percentage abundance of another isotope, fluorine 37, percentage abundance of another isotope 37 will be 100 minus x, because there are only two isotopes. If one is x percent, then other will be 100 minus x percent. So according to equation, average atomic mass is equal to percentage abundance x percent multiplied by its atomic mass 35 plus percentage abundance of another isotope multiplied by atomic mass of that isotope divided by 100. Average atomic mass of fluorine is given 35.50. So ultimately, on solving this by cross multiplication method, we will get 35x plus 100 into 37, that is 3700, minus 37 into x, 37x, is equals to 3550 multiplied by 100. 35x minus 37x, that is minus 2x, is equal to 3550 minus 3700 is equals to minus 150. So ultimately, x will be equal to minus, cancel by minus, x is equal to 150 divided by 2, that is 75. So percentage abundance or percentage of chlorine 35 will be 75%, and the percentage of chlorine 37, Cl37 isotope will be 100 minus 75, that is 25%. To solve such questions, if there are only two types of isotopes and the percentage abundance of one isotope is asked, then there is a trick to solve such question in few seconds. For this, you have to remember percentage of one isotope is equal to average atomic mass minus atomic mass of other isotope divided by difference of atomic masses of both isotopes. But this trick is applicable only when there are only two isotopes. And here it is also difference between average mass and atomic mass of other isotope. It is not direct subtraction. It is difference. It is also difference. That is higher value minus lower value. You have to remember this trick, this formula in case of such questions. Then if you learn this, then you can solve such questions in few seconds. For example, for this question, percentage of fluorine, percentage of Cl35 is equal to average atomic mass which is given 35.5, atomic mass of other isotope which is also given 37, which is larger value 37, so 37 minus average and atomic mass of other isotope difference, higher minus lower, that is 37 minus 35.5 divided by difference of masses in both isotopes. The mass of isotopes 35 and 37. So difference is 2. That is, and multiplied by 100 is equals to, it is 1.5 divided by 2. It is 0.75 into 100, that is 75%. That's all. Thank you. And now, molar mass. Molar mass of a substance may be defined as the mass of its 1 mole particles. The entities or the independent particles of the substance are 1 mole, and the mass of 1 mole particles is called molar mass of that substance. So, the unit of molar mass will be gram per mole. That is mass of 1 mole particles. But remember, if the constant particles or independent particle of substance is atom, as in case of elements, if it is atom, then molar mass is called gram atomic mass. That is, molar mass is called gram atomic mass if the particles of the substance are atoms. If the substance is made by molecules, then its molar mass is called gram molecular mass. If the substance is made by ions, then its mass of 1 mole of ions is gram ionic mass, and so on. Mole, so it is clear, mole here is also used as to represent mass. Not only number, mole can also be used to represent mass. That is why 1 mole is also called 1 gram atom if the particles are atom. 1 mole may also be called 1 gram molecule if the particles are molecule. And 1 mole of ions may also be called as 1 gram ions. But here is a little difference. If I say 1 gram atom of iron, it means 1 mole of iron. But if we say 1 gram of iron atoms, then it is the mass of iron. It is the mass of iron. It is not mole. It is just a mass 1 gram of iron atoms. For example, relative atomic mass of oxygen is 16. So, atomic mass, that is mass of 1 atom of oxygen, will be 16 AMU. We have studied 16 into 1 AMU, that is 16 AMU. Gram atomic mass of oxygen means mass of 1 mole oxygen atoms. Here the particle is atom because atomic mass here. So 16 AMU, that is mass of 1 atom into 1 mole, Avogadro's constant. Gram atomic mass or molar mass of oxygen atoms is mass of 1 atom into 1 mole, that is Avogadro constant. We have studied that 1 AMU is equals to 1 by Na gram. So we replaced AMU here 1 by Na gram. Na cancelled by Na, so it is 16 gram. From this observation, in general, we can learn that if relative atomic mass of any element is represented in grams, relative atomic mass is represented in gram, then it becomes the mass of 1 mole atoms, that is gram atomic mass. And if relative atomic mass is represented in AMU, then it is atomic mass, that is mass of 1 atom. Atomic mass. Here AM, atomic mass. Relative molecular mass. Relative molecular mass is the sum of relative atomic masses of all the atoms present in that molecule. For example, relative molecular mass of oxygen gas is equal to sum of the relative atomic masses of two oxygen atoms, that is 2 into relative atomic mass of one oxygen is equals to 32. From this observation, we can also say that if the relative molecular mass is represented in gram, then it becomes the mass of 1 mole molecules, that is gram molecular mass, 32 gram. And if it is represented in ANU, then it becomes mass of 1 molecule or molecular mass, 32 ANU. So it is clear, 32 gram of oxygen contains 1 mole oxygen molecules and 16 gram of oxygen contains 1 mole atoms. So guys, or 32 gram of oxygen had 1 mole molecule. What? Molecules. On the other hand, 16 gram oxygen has 1 mole atoms because it is gram atomic mass of 1 mole atoms. It is gram molecular mass of 1 mole molecules. Okay? And now guys, the question. Find the number of moles in 80 gram of oxygen gas. Solution. By unitary method, as we have studied in class 5th or 6th, we know that molar mass of oxygen in case of molecules, oxygen gas, that is molecule, so it is gram molecular mass of oxygen is 32 gram. In other terms, we can say that 32 gram of oxygen contain 1 mole molecule. Therefore, 1 gram of oxygen will contain 1 by 32 mole of molecules. Now, 80 gram of oxygen will contain 80 into 32 mole is equals to, it is about 16 to the 32, 16 5 ja 80, so 2.5 mole. It is not class 5th. You should not use unitary method, so you can formulate these data. What is this? Number of moles. So, number of moles is equals to, what is this? Given mass, in which we have to find number of moles. So, is equals to given mass of the substance, but it should be in grams. It should be in grams. Given mass which is to be converted into number of moles in gram, divided by, what is 32 here? 32 is molar mass of that substance. So divide by molar mass. You all know very well that the unit of molar mass is gram per mole. That is, molar mass of oxygen is 32 gram per mole. That is, mass of 1 mole is 32 gram. This formula now can be used to find the number of moles from the mass of any substance. Or if you want to find mass of substance in gram, then you should know number of moles into multiplied by molar mass of that substance. By these formulas, you can convert mass into moles and moles into mass. That is why mole can be used as or to represent mass, not only